May God's peace and mercy be on all of you, my friends, and welcome to another lesson on industrial biotechnology. Our today's topic deals with an introduction to industrial microbiology. Traditional fermentation processes, such as those involved in the production of dairy products and alcoholic beverages, have been performed for thousands of years. However, it was less than 150 years ago that scientific basis of these processes were examined. The birth of industrial microbiology largely began with the studies of Pasteur in 1857. He finally demonstrated that alcoholic fermentation in beer and wine production was the result of microbial activity, rather than being a chemical process. Pasteur also noticed that certain microorganisms can spoil beer and wine, and that some fermentations were aerobic and others were anaerobic. He went on to devise the process of fermentation, which was originally developed to preserve wine. Of further advances that were followed, none were more important than the development of pure culture technique by Hansen at Carlsberg Brewery in Denmark. Pure strain brewing was carried out here for the first time, in 1883, using the yeast isolated by Hansen referred to as Saccharomyces carlsbergensis, which is now classified as a strain of Saccharomyces cerevisiae. Around the turn of 20th century, there had been major advancement in the large-scale treatment of sewage, enabling significant improvement in urban communities. However, the first novel industrial-scale process to be introduced was the acetone-butanol fermentation, developed by Weizmann in 1913, using Bacterium Clostridium acetobutylicum. In 1920s, industrial fermentation process was introduced for the manufacturing of citric acid. In 1940s, antibiotic penicillin was produced by further innovations in fermentation, and not only did production rapidly move from small-scale culture to large-scale submerged fermentation, but it led to great advances in both media and microbial strain development. Most recent progress includes the ability to produce monoclonal antibodies for analytical, diagnostic, therapeutic, and purification purposes pioneered by Milstein and Kohler in the early 1970s. However, many of the greatest advances have followed the massive developments in genetic engineering, recombinant DNA technology, over the last 20 years. In recombinant DNA technology, we have the donor organism from which the gene is transferred to the host organism by using a specific vector. Host can be prokaryotic, E. coli for example, or eukaryotic, for example yeast. A vast range of important products, many of which were formerly manufactured by chemical processes, are now most economically produced by microbial fermentation and biotransformation processes. Conclusion: the birth of industrial microbiology began with the studies of Pasteur in 1857, who finally demonstrated that fermentation was carried out by microbial activity. Pure culture technique was developed by Hansen in 1883. First novel industrial-scale fermentation process to be introduced was acetone-butanol fermentation by Weizmann in 1913, using Bacterium Clostridium acetobutylicum. In 1920s, industrial fermentation process was introduced, and, in 1940s penicillin was developed. Over the last 20 years greatest advances have followed the massive developments in genetic engineering. That's it for today's lesson. I hope you guys have learned something. Don't forget to subscribe, and I will see you guys next time.